So, yeah, game dev degrees are fairly darn popular. You know, outside of UM. So.
Yeah, I was just looking because there's another couple in the area that are shown.
Yeah, absolutely. I mean, I still haven't taken on CCS, which I'd like to.
Yeah.
So I'll need to run through a few more contacts to do that.
In which case, let me know. I got a few friends in there.
Fantastic.
Oh, awesome.
So, yep, I'd like to do that. MSU is a little far away.
Yeah, I was looking at Ferris too, but they're 2 hours out.
Yeah.
And they were really nice program.
They're only 2 hours out.
2 or 3 hours.
Oh, it's 3?
This is 2 hours 47. That's 3 hours.
Oh, that's 3.
Is Ferris over toward
Grand Rapids?
Yeah.
I think it's in Big Rapids. Like right down there.
Not engaged.
Yeah. I've been there once to see a friend, and just about all I remember, they had a fantastic cafeteria. Really, really fantastic. Which is Ferris? So I was very, very impressed.
A former student of ours is teaching over there. Cool. Yeah. So check out game animation, I think is the course that he did.
Cool. I would love to have a course like that at UM. Very happy. But one of the things we'll need to do is we will absolutely need to try and find another course department. I think our UM games look pretty darn good. I don't think they look good enough to win festivals or competitions, most of the games. So we would like to find a course to team up with. And in fact, Jeremy and I were talking about how the way MSU sets up their game course is that it is kind of a cool, like, client freelance relationship where a bunch of games will be made by engineers and designers, and then the artists will actually create several different looks for each game into products. And then those looks, those aesthetics get matched up with the devs who want those looks, and they actually finish up the game polish up. It's really good.
I was thinking of that game dev should be more, well, let's just make something with no juice, no aesthetics, just placeholders and
if it's fun, then you know it's going to be fun.
does the concept work?
And then change it after the placeholders are in. I ship it. Call it green light.
Call it N plus.
Seller to our DLC 3.
There you go. There's a place for you to look at my business off.
The code is separate. That sounds dangerous.
The first milestone, they're like, oh, we want this to look like the best ever. Like we have to put like so many more hours in it. Like we're just gonna scrap all of this. We just keep it functioning.
So that's kind of what we all want to do. But next year, we really want to push it backward a little bit in making sure that those prototype systems that go in early on do not last until the end of the project. I have seen
Refactoring, what's that?
I've seen a lot of student coders. So much good as I see more and more.
I got yelled at.
Suggestions are taking multiple weeks to get it.
I got yelled at for refactoring at my job. They're like, don't refactor, it's bad. You're going backwards, not forwards. We need to go forwards. We have it working. Don't go backwards.
Yeah, those were literally the words.
No, I tried to explain it, and then it was kind of like,
I'll talk to you next week.
this is like a web guy. Like I found working with web designers and web programmers, it's like some of these lower things don't personalize.
So your bosses, your supervisors, maybe they're into investing.
You tell me I'm making fish wraps in newspaper.
So imagine if every feature we built from here on out was made half as expensive. I can make it twice as cheap for you. If you give me this one day, we'll fix this. Would you do it? I would say yes.
He didn't like my long hair. for the long run.
Sometimes
I love spreadsheets. Be like, here, this
make
is.
sure this content.
Hiding under a hat.
And my tool
A lot of us hiding under a hat.
give you $10,000. Maybe.
No. Well, I mean, they'll be like, oh, that's a what if. Instead, if you have like a spreadsheet, it's like, spend one day on this, these are savings, and give them like concrete.
Not
Not
smearing it, but
Save.
that's exactly the
Look at
fact.
and plug into other spreadsheets.
My issue is I need to interview the company more. That's what I need to do. I'm interviewing them too.
You know, the guys waiting were among our first external presenters did a pivot and that went out to work for University of Michigan, Stanford. Of course, there's so much opportunity. So do you work for Quicken?
Yeah.
Oh, great.
The last boss, we were kind of
I'm sure
the same
Quicken
teams for a
needs
while. But then, like, he kept
My
making me do, like,
entire field was
You've done a lot.
quantified.
Yeah,
We do invest.
Yeah, oh yeah.
Are you for your first?
Yeah.
Okay, yeah, I think I will.
Yeah, so yeah, we
Trying to see more traces of,
I played this game, I lost, I was like,
yes, I could not go like that.
what's the project to do?
That's the more like serious games. Like we had wireless gamification, we just do advisory with it because
the kind of thing of, oh, I have to connect automatically on my.
and so then we were like, this is what it
I mean, from my presentation,
actually looks like, and they're like, okay, that's not good.
can I, would you be able to share the presentation? Wireless share, let me give you one of my business cards. Because I really do, I've got to be back here at 7:30 and I'm like 40,000. But I'd love to see the presentation.
I'll take that too. Thanks for it. Close to the front of the class. So how are you doing? I'm sorry I've missed so many of these.
I recommended you today, and I've got some shit.
I appreciate you. Well, I care enough I can have the conversation as director.
This, the same week.
Patents are for scientists. I'm a lowly econ major. Yeah, so I'm interviewing him. He doesn't ask if I
keep in touch, be good. Don't do anything stupid while I'm gone. If you do, call
We're in
and
the
say, I'd
games
like to be
business, we
included.
specialize in doing stupid
I'd like to be
things.
included, so, you know, I feel bad.
Then died in 1980.
Oh, wow.
Smoked with,
5 minutes for them to get started. Have you got yourself a drink? Do you need something over?
I'm not familiar with the name, but I
Good
apologize.
time to start drinking.
and it was just more curious.
I finished off my Glenn
Sure.
So it's that guy setting up the new
That's cool.
We're so we've got
Yeah, no, I did economics.
so we were thinking about Las
We
Vegas.
did economics and mathematics to go with my law. So that's why I'm a business lawyer, not a litigator.
Absolutely thrilled to agree at the same time.
Yeah, that makes sense.
There's a great book called Pacific Eastern Standard Time. And basically the premise is that, before the internet, we're doing gravitate.
I gotta tell you, I know it's not fun for the company, but the lawyer in me is enjoying the sniping online between your company and certain other Toys for Bob.
I can't.
I know, I can't comment either. I just have to say, it's pretty interesting. Rambling on and he goes, oh, you guys work in a lot of I actually thought, you know, I am a lawyer, I thought Brad likes to litigate these things online, and I thought that the timeline was an interesting choice. When that marketing I thought, that's an interesting choice. But Star Control 2 is my favorite game of all time. I'm still a founder of Star Control Margins. Looking forward.
The square box, the robots.
It's moving at a very rapid pace.
I made the trailer for that, and like
Is
Harry
it
was
Scott
like,
that he's supposed to do gifts planet?
He has
I love them. He did one. He just had the lightning strikes. It really did, I thought, capture what it was, what the original felt like. The lightning comes on.
It's been very exciting to see his screen.
I bet.
Oh, yeah, sorry. I can see you too. How are you doing?
any semblance of balance. And like, I still suspect we ruined it for like the last.
Let's talk about CCS grads.
The
That
shield
one
was
right here.
Oh, cool.
Kill him at Austin. Hey, how's it going?
I don't think so.
Okay, we should leave.
Okay.
But I need to make sure we're friends. We're gonna give it about
2 more minutes. 2 more minutes. I would say. So Austin, if you ever came to my house, I have an original Achilles hanging on my wall. I still have it. Scar.
Sorry, it's
Any days that I was there with the old days. This is more about me than.
I can't imagine.
So this is your first time here, right?
Yes.
Publish.
Yeah, just throw it in.
Okay, that's what I was looking for. Let's see if I can dig up. I've got a picture of me with Nathan, Scott, Paul, and Kevin Manning. Hey.
Hey, Alex.
Ready?
Jared, you ready? Okay, ladies and gentlemen, thank you so much for coming to this April meetup of the IGDA. We have 2 absolutely phenomenal guests with us today with some really interesting topics. First up, we have Jared Burkart. Thank you for coming. Is it your first time coming?
No, I was at the last.
Awesome. Very cool. Who's here for the first time, by the way? Fantastic. Fresh faces. Excellent. So Jared graduated from ITT Tech in 2013. He was offered a job at Quicken Loans, which you might not associate immediately with games, but as we're going to learn today, they absolutely do some cool game dev stuff. So Jared has worked as a game designer, has worked on serious games development, games for stuff like marketing, and he knows, he has a lot of experience what it is like to make games at a non-traditional gaming company. So everyone, let's welcome Jared Burkart.
Thank you. So, yeah, as said, my name is Jared Burkart. I have been working at Quicken Loans for the past 5 years or so, and I am a game designer. So, a little bit of background on me. I've done video game design. I've basically have been doing that for the past unofficial hobbyist game design since like 2001, back in like Macromedia Flash days and stuff like that. And then a few years ago, I started getting into audio design and audio engineering, messing around with some virtual synths and stuff like that. I have a few friends who do music over in Ferndale and stuff like that, so have kind of shared in the experience with them. I participated in a few of the game jams at LTU. So here's the two that I've worked on. The one up top is just a little game of like figuring out pieces and killing people with traps. Then the bottom one is a just random game of just random stuff, and basically as many puns as we could figure out. So yeah, as I said, I'm a game designer at Quicken Loans. I've been there since 2013 till now. And pretty much every time I say what I'm doing, people always ask, like, wait, Quicken Loans does video games? Basically for the last 5 years, every time I've talked to someone, whether it's at GDC, at one of these, or just talking with anyone on the streets. So the main part we do is serious games. So this was the first game we made that was meant for testing knowledge and helping bankers get ready for their exams. So it was a multiple choice thing. We have achievements in it, badges, we had leaderboards, and we even gave rewards out for people who placed higher on the leaderboards, stuff like Red Bull, Buffalo Wild Wings gift cards, you know, stuff bankers like. We've also made games for simulation and also just intern experience. So Amp It Up is a game that we use for software simulation. AMP is what a lot of team members in the company use in client-facing roles. So we help build a simulation to where they can develop the muscle memory of navigating through the labyrinth of that software, because it's super expensive. It took us a while to even figure out how to do it ourselves. Then Clue is something that we made last year and we're rebranding for this year, which is designed for, we have locations spread all around Detroit, and we give little breadcrumbs and pieces of knowledge about Detroit, so then people can go out and find those places. So as we get interns coming into the company, they turn into ambassadors of Detroit. And so as Detroit's growing into this great place, we want them to go out and experience it. They don't just come in, clock in and out and leave. That they're able to go out and experience, you know, what people of Detroit, the shops and the places. Snapchat for marketing. The first one was Barry Sanders Dodgeball we made last October. And that's the website link that if you ever want to go to it, you can. It's more friendly on mobile. Or if you have Snapchat, you can use the Snap code. They approached us and were like, hey, we have an ad campaign that we're doing with Barry Sanders. He's playing dodgeball and stuff like that. We'd like to launch a game on Snapchat as part of an ad campaign. And so we hopped all over that. And then we also worked with Avengers and Marvel for the so
there's a Wi-Fi connection.
Yeah, we'll be fine.
No.
So we paired up with our marketing team again and made a game based off the commercial that we have, the commercial spot that we have that we paired with Marvel and with Disney and them. So I'm going to talk about the development process that we currently have and some of the things that we've established there, because that's one of the challenges, is taking the development process that, you know, we're kind of used to, that we've kind of learned going through school or currently going through school, of like the game design process, but then applying also that non-game development process that technology teams have, especially a technology place like Quicken Loans has. So one of the first goals we wanted to have was to have a continual workflow. You know, we didn't want to have these periods where we released a game and we had this downtime. Especially being full-time employees at Quicken Loans, you know, they're not gonna keep us there, just sit on our butts until we find the next project. So we wanted to establish this continual process that we're constantly working on a project. We're constantly working on a game. Also, we wanted most of the games that we made to have a unique aspect or a mechanic. So if we made one game that's used to test knowledge, we also want to we didn't want to just make the same thing with different lights or colors on it. You know, we always wanted to make something new that can solve a new problem. And so then also we wanted to establish some of the non-game development processes to our workflow. IT is one of those things that they constantly can get a lot of that process distilled down to get their engineers constantly working on things that are effective and impactful to their processes. So the part I tend to spend most time in as a designer is the pre-production. So is anyone a designer here, or most of you programmers, artists? Students. Students? Lawyer. Awesome. So this is where I spend most of my time in, and this is where I sort of help shape and develop our intake process. So we tend to have 3 stages before we start working on a game. And so I'm going to quickly go through these. The first one is the requirements meeting. So we meet with our business partner, we meet and get, what we want to establish, like what does this need to do? For either our students, a lot of it is like, what does the project need? Like, what are you being graded on for the project? But then the last part, establishing the goal of the project. Like, what do you want to accomplish with that? What are you looking to make the outcome of this project? And so going a bit more into, what is the goal? What are you looking to accomplish? When you're going to develop a game, like, what do you want the outcome to be? And you can't say money. Like, money should never be that goal. We have different philosophies at Quicken Loans. We call them isms. One of them is numbers and money follow. They do not lead. And to basically summarize it, through that middle part, you chase the great ideas. You chase after the designs. You chase after that piece that accomplishes that goal, that what you want to have. And if you do that, then that success, that money that you would like out of it is going to follow. So we'll use some examples. The example I'm going to show is through Pixar. No, none of this is probably official from Pixar. It's just my own personal view and hypothesis. So the first one is Toy Story. So what's the goal with Toy Story? So if you know Hollywood, they usually don't take risks. Like, they will make movies that are a sure bet that's going to make money, because that's their goal, is just making money. So, but their goal, the first feature-length CGI movie, it's never been done before this. That was the goal they wanted to accomplish. And so, which turned out to be super successful. And so then, the next movie that they come to put out, they have a goal with this. And it's not just, oh, well, yeah. So, CGI hair. If you think about most of the CGI before this, all the hair was very solid. It didn't really move.
Static.
Yeah, very static placed hair. I mean, look at Sully, how much hair is on him. And if you notice, every movie after this that Pixar released, and a lot of CGI movies after this, had that flowing hair, had that dynamic hair that moved with the characters. WALL-E. What's the goal that they had with this? So Stanton, the director, felt Pixar had created believable simulations of underwater physics, was willing to direct a film largely set in space. WALL-E has minimal dialogue in its early sequences, and many of the characters do not have voices, but instead communicate with their body languages. So the first part, believable simulations of underwater physics. That was the goal of another movie. What movie was that? Finding Nemo. Now, if you know anything about NASA, they do a lot of their space simulations underwater, because that leap from underwater physics to space physics isn't too far of a jump. So
Except for momentum.
yeah, except for momentum, but it's still easier to make the jump from that versus having above ground physics. So then, the goal of Wall-E. Can they tell a story where the main characters don't really have dialogue? Like, Wall-E says what, 2 words, his own name and Eve? Otherwise, he really doesn't say much. And so that was part of the goal. They wanted to see if they could tell this story that people loved and grew with without really having to say much. And so once we've established the goal and what we want to accomplish with that project, we then have a concept. We start throwing out the concepts. You know, how are we going to solve this? So after we have the goal of the project, we spend 2 weeks just coming up with whatever ideas we can. Like, we throw everything at the wall. Like, and then at the end of that 2 weeks, we all sit down together, go through our ideas, and figure out which one will suit it best. So we bring everyone into the concept meeting. Part of our team are non-game people. They do more support for training teams. They're more your standard IT developers. And so we even bring them out in this, and we even made a guide for non-designers how to write a concept doc. Like, if they can just answer the first 3 bullet points, they have an idea we can run with. And so we give this for everyone on the project, our artists, engineers, everyone, because everyone will approach the problem differently and may come up with a solution that's better than anyone can come up with. Now, the non-designers don't have to have an idea. If you're a designer, you have an idea. It doesn't matter if it's good or not, you have one. For Avengers, we had 9 concepts out there. So we had a lot of them were just throwaways, like, that's stupid, it's never going to work. But through
But it might also inspire something, right?
Exactly. So then at the concept meeting, we gather everyone, all the people who made their stuff get up, they pitch it, give their stuff, we vote on which one we think it's going to, which ones we think are best. So with the Avengers game, we narrowed it down to the top 3 we felt were the best to go with it. So then after the meeting, me as the designer, I put all of that together into a pitch doc, which most of you, I hope, know what a pitch doc is, or have written one. So then that's where we go to the pitch meeting, and we bring the ideas to our business partners, the people, your producers, whatever. And so before that, we have every concept refined into the pitch doc. We have an idea of what will be required from our business partners for each idea too, because when we work with training teams and making games for training, we don't create the content that will be filled in that. So the first game we had with the multiple choice questions, we don't create the questions and answers, our training teams do. So we need to be able to tell them, with this idea, this is the work you're going to have to give to also make this game successful, because we're not going to write all of that for you. So then after the meeting, either at the meeting or after, because sometimes they need to take the idea to their teams to decide on the idea, they choose which one they want to go with. So for the Avengers thing, our marketing team also had to send it to Disney and Marvel for approval for what game they wanted, and also to Snapchat for which one they think is the most viable to even run on their platform. So once all of that is done, then we finally start writing our GDD.
So for those of us that may not have been in that type of environment, it's absolutely similar to the process that we go with, or one-to-one correspondence process that we go with when we work with the publisher.
Yeah. So for our GDDs, most of them take about 4 weeks, at most 4 weeks to write. We usually never spend more than a month writing a GDD. but obviously it varies with the scope, but we average around 5 to 10 days. We usually never spend more than 2 weeks working on a GDD. So like right now we have a few mini games that we're making, and those usually take about 3 days average to write. So also, if you're not writing the GDD, please read them. That cannot be stressed enough, to read the documentations as they're being written. Into the next point of giving our business partners, the producers and publishers, we give them, like, the second we have our first save, not even our first rough draft yet, give them the view like, hey, here's the thing, you can watch it as it grows, keep an eye on it. And then our development team, we save the doc to the cloud so we can just share it with them, edit it. Also, when it's being written, if you're not the designer, ask questions. If something isn't, if you don't know exactly how something works, ask. Like, come up with those questions, because as a designer, you know, we're usually in the thick of it trying to make sure we cover everything. We're gonna miss a lot because we have so much that we're trying to get to paper. So ask questions. I usually pass it to my engineer, and he comes with pages of questions that helps me refine the GDD even more. So then once the GDD is finished, we move to our work breakdown. So our work breakdown is where we start to establish what it's going to even take to make the game and how long it looks like it's going to take us. So what work breakdown looks like is we first break it down usually into 3 to 4 categories. What's all the art that's going to take place, what all the programming is going to take to make this game, all the audio we're going to need, any iterative designs that are going to need to take place with it. And we break it down even more. So we don't just have art UI. We might have art like game UI, out of game UI, what do the menus look like, what does the logo look like, and how long are we going to be spending on it. And so then we ask, how long is it realistically going to take each task? Because I don't know about you, but as artists and engineers, you could spend 5 minutes on a task, or you could spend 5 weeks on a task because you want to get that just right. You're going to make an entire shader to do this one little thing that you could probably do with 4 lines of code. And you're never going to use that shader again because you actually found a better one on a website that does what you need to do. So at Quicken, we use agile methodology. So we work in 2-week iterations. So ask yourself, what are you going to be able to accomplish in 2 weeks? And that's where how we break down the work. What can you do in a 2-week iteration? And then we also identify any roadblocks or unknowns. So that clue game that I mentioned with the interns, last year was the first time we made it. We've never worked with GPS before, or like map locations. Like, we've never done anything like that. That was a huge unknown. We didn't even know what companies out there had, what technologies we had. So that was something we immediately need to identify. We don't run our own databases. We don't run our own servers. We have teams for that. So we immediately identify those are the things we need, and these are the things we don't know, and how can we accomplish those? And then we can immediately let those teams know, hey, we're going to need to get databases from you sometime in the future. We don't know exactly what's going to be on them, what tables they're going to have, but be on the lookout because we're going to be coming to you, so then they can prepare with whatever workloads they have. So then we also prioritize the work. Like, what do you need to do before you can get other things done? Like, what mechanics are necessary to get done before you can add other things into it? Also, identify any work dependencies. Like, can you not do something until a database is set up? Okay, then we need to reach that out. And then that's when we plan our project timeline. And so then, after all of that, that's when we finally turn around and set our release dates, which is where a lot of stuff tends to, as talking with other developers, can differ. In college, your professor is going to set your release date for you, so you can't really say, oh, it's going to take me this long. You need to match your work to fit.
I've been in college for 16 years. Should have that first assignment done soon.
Yeah. So, but then, if you know how long it's going to take you to do work, that's when you can set up expected demos. That's when you can set up these show and tells, like, hey, this is when I know I'm going to have this part done, so I know when I can show it. And you can also set up lines of communication, not only with your business partners, with the people who want the game made, but also within your team. Because then you can set up, okay, when these things are going to be done, art-wise, so then that's when the programmer knows they can pull stuff in. And they can actually make time for those things. So it makes the team run a whole lot more efficiently and and faster. So as we've established this process and as we've worked, most of the games we make have a 3-month development window. So, like our mobile game, we did a complete overhaul and rebranding. The only thing we have similar from the one we made last year is the GPS stuff, and that took us about 3 months. The Avengers game took us also about 3 months.
Is that including approvals? You had to go through
Yeah,
some.
yeah, we're gonna run through that.
Okay.
So, also, our business partners, the people who we're working with, know exactly what to expect and know when it's happening. Especially working with someone like Marvel and Disney, like getting that stuff out, like this is what it's going to look like, this is where things are going to be. That is something that, you know, the business partners and producers and publishers, like if you can have that set up, they're going to look. Also, the development team is all on the same page. Everyone knows what everyone else is working on. Everyone knows what's entailed in the entire project. They know where their part of the cog is in the machine. There's a few projects we've had that we didn't have that development set up, and half the time our engineer was like, what's this? Like, when was I going to know about this? Like, now I have to rewrite all this code because of this mechanic that I wasn't told until 5 minutes ago.
That never happens.
Yeah.
Never happens.
And as we set the release dates and we know how long it's going to take, crunch is self-inflicted. If we estimate wrong on how long something is going to take, if we're like, yeah, that'll take me a week, and then it takes you 2 weeks, well, the crunch is because you didn't fully realize how much work you actually needed to have. So, and I said usually because sometimes things happen. So, to give an example, so we were able to work, like I said, like I've been saying, we've been able to work with Disney and Marvel with the Age of Ultron release and making marketing for that. So we had about a month of pre-prod, a month of development, and a month of testing. So we were told that we were probably going to have the project near the end of December. We're looking at like between the Christmas and New Year's Eve break. About a week after New Year's, we were brought in, we were shown the storyboards and all of that. We were given about a week to come up with ideas for the game. We made the pitch, sent it to them. By the end of January, Marvel came back and said, this is the idea we like. Snapchat also said the same idea was probably the best one. So then we had a few days writing up the GDD, all of that. And then all of the month of February was just pure development. We broke down the work about the weekend before February, and then we just hit the books and everything. We were told by marketing that Marvel usually has about a 10-day approval process, so when we send them something, we'll probably not hear back from them for 10 days. So we needed to take that into account because also the release date for this was April 4th. So we needed to make sure we had enough time to go through that process. And so beginning of March basically was just pure testing. The game was made. The only things we needed to change every now and then, if there was a logo that wasn't in the right positioning, that needed to be changed. If you've ever worked with marketing, they will look at every little detail. Even in our pitches, I like to throw jokes. So like if I have dialogue boxes, I'll just take popular movie quotes and populate them with that. And I'll just see if people can guess what movies they are from. Sadly, that doesn't always work. I'll have a Casablanca quote and someone who's twice the age of me won't know it. I'm like, what the hell?
You give me their names, I'll take care of it.
Yeah. So, but this was the second game we worked with marketing on. The first game was Barry Sanders Dodgeball. So this was before they realized how long it takes to usually make stuff, which that's usually where a lot of the tight release dates come in, is the lack of knowledge of how long development actually is. So this, we had 2 days pre-prod, 8 days development, and 2 days of testing.
Schedule works just fine for me.
Yeah, so
Massively multiplayer, right?
That is agile.
yeah, so we were told, hey, we have this idea, and stuff was already made, and it was one of those that our chief marketing officer was in a meeting with one of their leaders, and was like, wouldn't it be cool if we had a game with this? Like, we have a commercial where he's playing dodgeball. What if we made a game where you're playing dodgeball with Barry Sanders? Because it's Barry Sanders. And the leader is like, well, there's a team that makes games. Let's ask. And so they also did all the research, like, hey, we can do it on Snapchat. We already have an ad campaign with them. So they were like, all right. So we got on the call with them in Snapchat. Snapchat says, when are you looking to release this? Oh, the 30th of this month. And it was the 12th. And we're like, oh, that's good to know. Because they also you should have the game up 5 days before release. So, because they need to do their own testing and load support. And then we also needed to make sure we had servers set up, and also when it goes live, make sure that our company servers can expect anticipated load and all of that. So we had 2 days where we were throwing ideas out. We had about 12 ideas, narrowed it down to 3, sent it over to them. We also had football ideas in there because we didn't even know what the commercial was.
Right.
We just knew it was Barry Sanders. That's it. So we had football ideas. We also knew that dodgeball was involved, so we had a few dodgeball games. So then, like, we were able to see the commercial, and we're like, okay, we're doing dodgeball, we're not doing any of the football. Like, we were thinking some, like, Tecmo Bowl stuff. If you notice, it has a super dodgeball look, because after we saw the commercial, it was like, okay, we need it to be like super dodgeball. You know, back from the heyday when Barry Sanders was there, was also that style of graphics, so it just made sense. So, and it basically felt like a 2-week game jam, essentially. Like, we were there from 7 a.m. to like 9 p.m. and it was fun. So, some of the takeaways that I have is, you know, establishing the goals and the pillars of the game before you work on it. At this last GDC, the guys from ID talked about Doom and how their goal was that push forward combat, like just constant. We want people to constantly move. And a lot of their design adhered to those pillars. And so the pillars of that game. Like, this is what we want out of the game. And so when you go to make art or to program something for the game, ask yourself, does this add to the goal that we want to accomplish, or does it subtract from the goal? It's going to be one of those two things usually. And if it adds to the goal, then great, let's see if we can work on it. If it takes away from the goal, then this might not be the project to implement that in. Also, focus on making a great game, not money. Like, that's one of the things that we have at Quicken Loans. Like, focus on making a great product, focus on making the experience great, and success is going to come from it. And then everyone is part of conceptualization. Like, everyone in the process. Like, we even involve marketing. If they have an idea for a game mechanic or something, we love to hear it. We're like, okay, here's how you write up a concept. Write that up and send it over to us. And then the iteration on the process. That's one of the things that, you know, either we iterate on a new release of the game, like with Clue, we didn't have too much time for testing before release. So this year we're making it bigger and better by improving the experience of that game. And then let the developers set reasonable dates. Like, that's one, we have another ism is, it's not about who is right, it's about what is right. And so we can have moments of push and pull between our, you know, business partners where they're like, I think the game should go this way. We're like, well, we feel it should act as the subject matter experts. We feel this is best. That they're not like, well, I'm, you know, I outrank you, so we do what I say. So we usually have that great push and pull and dialogue between each other to set those reasonable things where, you know, hey, and we even told marketing after the very standard thing, hey, we loved working on that. Please, the second you have a campaign, let us know. Because the more time we have, the better game we can make. And that's it. That's my contact info. There's my personal and any questions?
So a question or a comment about developer time. We don't have any developers in here, do we?
No.
I always multiply whatever estimated developer gives me by 1.5.
Yep.
We got 3 over here.
It's not me.
I'm a lawyer.
Yeah.
I mean, that's just one of the things. I would also tell people if you're a developer, if you're working on stuff, it's not a race. Right? We'd really rather have accurate times than for you to say I can do it in 15 minutes. That just doesn't work. You know, and so that's just a general comment.
I like the philosophy. I like the philosophies you mentioned, but out of a non-gaming house, do you find that there's any additional friction with those kinds of conversations that you have to have, vis-a-vis the release date isn't right, or we have to push back, rather than at a gaming company where at Quicken Loans, maybe it's not their core competency, they're getting a new conversation with the game company inside.
So a lot of the times it's that first part of identifying the goal and identifying like what they actually want out of it. Because a lot of times they'll be like, we want a game, or gamification, you know, is a big buzzword. So like they're like, we want these things, and it was like, okay, well, what do you want it to do? Right. And like that's when you start, like at the beginning, just asking those questions, like, well, why do you want this? You know, and actually hone in and pull that out. Like we recently had a meeting where it was like, okay, well, we want to make a game to help teach the philosophies of the company and whatnot. And so like they were like, well, we feel like it should be a quiz game and stuff like that. And we're sitting there talking with them, and then all of a sudden we were able to pull out. Well, after the conversation, it was like, okay, well, actually, like, here's the part on why we're needing to teach it is we need it to be more of a dialogue between people of that teaching of the philosophies. And so that's where then we can come back and say, okay, this is what we see as that pain point, and this is how we feel it can be resolved.
How many people are on the team?
So we have 5 developers on our team. We have 3 artists, and then I'm the designer. Then we have a designer/engineer, and then we also have a whole engineering team that helps with like the back end, like server setup and stuff like that.
So what are some of the KPIs in which you guys are using in your iterative process? I mean, I assume that once it goes out, you look to say, well, we had a goal that was originally intended.
Yeah.
Did we hit said goal? And if we didn't, do you continue to iterate on that? Do you get closer to where you want to be and continue to move the needle? I mean, if you're not doing business to consumer, right? And I can say, hey, I need my D1 to D30 goals to be this, right? I know what my monetization rate should be. But in an internal B2B atmosphere, if you're trying to get somebody to get through AMP, I think you said it was. It sounds like it's an internal software that you guys use.
Yeah.
Are you measuring based upon if somebody gets all the way through it, what their end result is within the organization, how they're able to faster utilize that type of software? I mean, how are you measuring the success or failure of the different games which you're producing?
Yeah, great question. So first, we also, when we work with the business partner, we let them set the success criteria.
You make them measure it too?
Yeah. We get concerned when when we ask what type of metrics you want to track out of it, and they say nothing. We're like, no, like we need metrics. And so, Quantum, the first game I showed that we made, we track a ton of metrics. I think we have like 30 points. Sam helped make it, he knows. Like around 30 metric points that we track. Everything from what questions they get wrong, what questions they get right, like down to the very specific. And there's over 1,000 questions in the game. And in that, we're able to, they'll have, you know, a test group and a focus group and all of that. So they'll be able to track and see, like with Quantum, we could actually see and track, hey, if you get this score in our game, we know if you're probably going to pass or fail your exams for licensing. So amp it up. The goal for that is just to develop the muscle memory. So with that, we're doing a few iteratives on it as the trainers put it out there. They're like, hey, could we get this type of feedback in the game? Because right now they're only getting that feedback through the trainer. So we do a few of those iteratives. We also put out surveys, like outlet surveys for the people taking the game. Like, hey, like what did you think of it? Did you feel it was effective in the training? What would you change about it? So then we can actually get, you know, that feedback on if we need to change it for an upcoming release and stuff like that.
I'm really curious what the impetus to this group was. Was it like you had a charter of some marketing or IT or an executive who's like, oh, we really need to put together game dev internally?
So
how did this start?
It started, one of our artists, Mike DePonio, he came through as a banker, and when he was taking the exams and tests and whatnot, like when he was studying to take the licensing exams, as that, it's basically like getting ready for SAT prep. But if you fail this, you're not going to have a job. So they have practice exams, they have all this stuff, and like he's like, as he would say, he's like, he loves taking tests. Like he's a great test taker, he loves studying, but after so long, your brain just stops reading words. He's like, there has to be a better way for this. And so that's where he came up with the idea for Quantum. And so then as he changed roles, he put together a pitch and went to his leader in training like, hey, I have an idea for making a game, you know, to help bankers, you know, prep for this test and stuff. And he was like, all right, do it. And so me and 2 engineer interns came in, and that's what we worked on for the next like year. Like we spent probably the first 2-3 years of my time there just figuring out how this process would work, because nothing like this had really been done before. We've gone to Serious Plays conferences, and like no other company that we know of has done anything like this, of having a game dev team in their technology team.
As opposed to hiring outsourcing.
Yeah, they'll like outsource stuff like that, and that's one of the things that we feel benefits having us internal, because we have a greater investment on the success of the game. Whereas if you outsource, they'll come in, they'll develop it, then they'll just leave and move on. Whereas, you know, we deal with it every day. We build these relationships with these trainers and with, you know, marketing. So we have that shared investment on making it as successful as possible.
Any VR for your training?
We've been working on VR. So every Monday we have a thing in technology called Bullet Time, where we can work on whatever we want, as long as it either benefits the company or it's learning a skill or a knowledge. So on Mondays, we've been working in VR and stuff like that, and we've actually gotten a lot of traction with it. We were looking at making like Rocket Mortgage in VR, so you could get a mortgage while in VR, and we made it to where you could fly a spaceship. We made the solar system on a 1-to-1 scale, which when you make a level to house Jupiter and Saturn, it breaks. Your hands like twitch and break, and it's hilarious. But yeah, so we made that. We've also are working with security, like for fire drills. Like you have your headset, you're at your desk, a fire drill goes off, you know, because when you're in a company and they talk about safety, you usually just wait for the video to end. So we're looking at, you know, making security interactive to where people can be more prepared if any emergencies happen at work. So that's some VR stuff we worked into. So, any other questions?
I would just add to my previous question. It's interesting. I spent several years working with a defense contractor in an internal games team, which grew out of the training team, and our major customer was internal marketing.
Yeah.
And one of our other major customers internally was the safety team.
Yes.
I think there were some parallels there.
Yeah, there's a lot. Like, even though the team we're a part of technically supports the training teams, like if there's something that we see, like on Mondays, we're like, let's make a game for public consumption release, and we can do that. So.
Any other questions?
All right, thank you.
Jared, thank you. Okay, let's take about 10 minutes, 10-15 minutes, then we will come back with our second speaker, Jason Eaton. All right,
Great presentation.
thank you. Jared, it's really great. Thank you.
Sorry. Yeah. Thank you.
Also, Jared.
Yeah. Oh yeah. When like the second we heard the releases, oh, we want it by the end of this month. Like we all just stopped and turned and looked at each other, and our team leader immediately got off the phone and ran to to our VP and was like, "Listen, we need servers. We need all this now."
Immediately.
So I'm checking the deal this morning.
So you'll want to be a little bit careful about who No, we need to plug into
10 years after the first conversation.
No worries.
So how's life down the street?
So you know what the network cost code is?
So we're getting a lot of those somewhere. Development is moving at a very serious way. It's great to see like, it looks okay, but it'd be better. It's like, oh, that's actually really good.
I looked away from the project for a while, and then Scott and got some tweets back, and that used to be studies. Yeah, well, that's pretty smart.
Yeah, I don't do art or engineering.
Back in the 90s.
So like,
Yeah, I missed January, February. I had courses.
yeah, so like,
March, I had
this one like, and not just like,
It's mostly the slides.
I pressed on the start and
so basically the concept is when you look at
he was nice enough when I was at Huntington, I was doing venture capital work, I wanted to start doing more he was nice enough to go out to lunch with me and talk to me for like 2 solid hours. He was really nice guy. And I had grown up playing like set. I don't play 6 Degrees of Freedom was really cool. You get lost. One of the things that games that really helped me is that spatial awareness and that map, notions of where I am after I make a few turns. But that's cool. I'm sorry I missed that. I'm talking up there and I was coming and then I'm not. The appliance I'm sorry I missed the last one. I know you invited me to your class and I said sure. And I missed it. I was happy the last time you asked me. I just couldn't because I had a couple of other things. That's actually what not the March meeting. I was watching basketball, so we here. Fan of March Madness. But I know. Yes, I'm not being like, yeah, that team's better. It's all right.
Finally got his back with coach.
It's just taking it is. So the moment like right out what is what's the concept?
We'll try to have emotional relationship with the Michigan football team for the last 15 years because it's not great. It's not been great. But hey, you're still my team. Go Blue. But no, I'd be happy to. Yeah, just give me the info. You have my email? Yeah.
first they need to
you're in his class? Okay, yeah, you're gonna miss out on the startup law.
There you go. You can come back. I'm sure he'll let you sit in. Yeah, no, he asked me to talk about basics of contracts and organization and kind of ways to be concerned about liability and intellectual property really are the pillars of early stage gaming development. That's right. Get into the in between you and your contracts, and you're 90% there.
Just ask yourself what we've done currently.
He would declare bankruptcy.
Works for me.
My dad spent probably 20 years crying and Donald Trump on TV and that because of the number of times he just kind of quit the business and kept on recreating.
And that's where you skill. Because that's
You got the strongest homestead protection. No, I didn't.
So, like, that's where, like, you know, programs help. You know, it keeps it and so that's where it's like,
Yeah, no, see, I haven't bought it. I didn't read up on that.
and that's part of where my heart on the
That's what I would tell the client.
like, for us, it's a bit easier where it's like, oh, you have, I get,
Just a second.
So I was really just thinking that, okay, we actually know what
whenever I update it, right? I talk about the difference between gaming bars what's the yeah. So it's why and all the different types of the exponential and so just yeah, we have an engineering been the only designer okay, so yeah, like yeah, well, I'm very more designers because it's like last week I wrote and it's like and then just entering for our game.
There you go.
For our interning,
I think that should be a slot.
Because I mean, our team's audio engineer.
Yeah, unfortunately, the rules are always set up to be taken advantage of by those going out.
I'm still like,
Yeah.
Okay.
So let's see.
Some of these diagrams aren't going to be
There you go. We can have Kid Rock do it too. That's right. If Kid Rock's going to Daniel's ticket. Oh, this is going to go over my head.
It's gonna run right into you, man.
Hey, you know, my last math class was in 2002. I'm going to do my best.
I also recommend ABC Mouse if you have to be kindergarten.
It's the best.
Starfall?
What, which one?
Starfall?
If there's,
I don't know that.
Well, again, if you're paid,
Hey, I have an 8-year-old and a 6-year-old. I would say all of your educational help in some ways the school system is failing.
so, well, my son, like, if you want to hang out at school land, over there, you do that. Now, what brings you to Starfall? Starfall's one actually I would subscribe to.
I would subscribe to anything.
Huh?
Okay, ladies and gentlemen. Ladies and gentlemen, let's begin with our second speaker of the night, Jason Eaton. Jason is a longtime friend of mine. He's a leader in the Wolverine Soft University of Michigan game dev organization. He is a current web and mobile developer and a master of game engines, constantly making and tweaking game engines. And we're going to learn about a little bit of that today, game geometry and physics. Jason, take it away.
Okay, so I guess first I was going to start this off with a quick video, why this matters. Because, you know, a lot of people think you start to talk to people about this stuff and they're just like, oh, there's all kinds of engines out there and we don't really need to think about it anymore, and, you know, it's all done for us and stuff. But let's just look at this little clip. Okay. All right. There's a guy with a giant sword there. Oh, I dodged it. Oh, wait a minute. Everyone see that? So he's going to do it again. I think he's done. But yeah, all right. I think it does it in slow-mo after that. Oh, no, it again. This is Dark Souls 2, by the way. This is actually my favorite series of games, only, you know, it has some issues with the hit detection that, you know, can be very frustrating, especially if you've dedicated like 100 hours. So this is why I think it's good to,
What
you
was
know.
the headline of that? Why do people hate?
Why do people hate Dark Souls 2?
Yeah.
Yeah, it's I mean, Dark Souls 1, it wasn't so bad, and then like Dark Souls 3 wasn't so bad. Like Dark Souls 2 was done by like another group of people, so you know, it was, you know, there's stuff going on with that. But it's kind of notorious for the hitboxes are really huge, so you'll be like visibly way away from the. Oh, I gotta reload the file. You'll be visibly way away from the attack, and you still get hit. Okay, so. Okay. All right, so a little about me is I started programming games back in 1999 when I was still in high school, and back then there were no like real engines. There was actually no graphics card yet, really. I mean. Came out a little bit around the same time, but you really couldn't find any books on OpenGL. Basically, you were doing everything in software, so everything was still software rendering at that point in time. So this is my website. It has a lot of my demos, because back then, like I couldn't really make full games because, you know, I spent most of my time making engines for games, and then every time I make an engine, I'm like, all right, I'm ready to make a game. Like. DirectX should be updated and all my code would be deprecated and I'd have to rewrite the engine again. So that happened, you know, for several of my engines until actually I got into college and started doing, and actually we used the engine, which was Laird's, the first 494 game engine is when I finally got to make a game, again, after trying to make my own engines. But, you know, you can look at that website. And so back in 1999, if you're reading a book on game development and game design, it was written by this man, Andre Lamothe. Yeah, Andre Lamothe. He wrote like every single game programming book on the market back in 1999. And this is my first that was the very first book I ever had on game programming right there. And it went down into every little nitty-gritty of how do you write a 3D game in software, no graphics card, no shaders, just pure software rendering. So actually, the very first game I ever made was it was almost a demo. It was this guy right here. I can't even stand in front of it, but actually, this is actually pretty impressive for a first game, especially when there was no engines. And I wrote it from DirectX from scratch because it has it actually has like a 2.5D scrolling engine. And it actually uses lots of geometry and collision detection with these guys. Like you can jump up on these boxes, and then there's a full-blown fighting engine in this, like on top of this. So when you're on like on the same Z-plane, there's actually like hitboxes. And I had a hitbox editor, so like each of these guys had hitboxes and stuff. And all this was software rendering. But this took a really long time. I didn't do any homework in high school. That was one issue. I would sit there in class. I would come home. I wouldn't do any homework. Somehow I'd get like, I got like C's. But I made that. So some of the teachers were impressed. So I actually had so actually that was another thing is I had a programming class in high school. My first programming language was BASIC. So I'm just going to explain why I kind of got into writing such low-level stuff, and it's because that's what you had to do when I got started. I also have a first attempt at my networking code. It's a 2D side-scrolling kind of game engine that has actual net code that actually worked. It was pretty amazing. Yes? Yes, thank you. That would help a lot. Thank you.
And you can also distract cats in case that comes up.
Nice. Okay. Yeah, netcode was really easy to make back then because it wasn't really on the internet. It was just over a LAN, so you could just send input to everybody and there's no lag. So, that was really easy actually. So actually, this is one of my games I made for the 494 class. So I used actually it was a combination of using the engine that was in the 494, but I was trying to rewrite my collision engine from scratch with a fighting game, but I realized 3 weeks was a little too little time, so I literally just took the code from my fighting demo and just threw it into the game, so I didn't really have to write any code. It only took me like 3 days to make this. And then my friend got to make 90 frames of animation for each character. Nice. Yeah, each character has 90 frames of animation. So he went and had one of those tablets, and one of his friends actually drew out everything on paper, and then she gave him the pieces of paper, and then he went and actually traced it on what do you call it, one of those tablets? Yeah, one of those. So, and then he colored them all in too. So he spent a lot more time on it than I did actually. He didn't do any programming. That's all he did, and that's I was happy to do the programming, but that was actually a pretty impressive game too. Yeah. So also I've worked with both 3D and 2D collision engines. Like this was done for a 494, not a 494, I'm sorry, for a 48-hour game programming contest. This was actually the very first 48-hour game contest at U of M, and we ended up using the Open Dynamics engine, ODE, to make this Marble Bandits game. So that was fun to make. It happens really fast, and this is the game I'm going to show in a minute. It uses Box 2D. So, and then I've also made, so this is a 3D engine that I made myself from scratch. And this is also a 2D kind of platforming engine. You can kind of see a little blue character right there. This is also from scratch. So the real question that comes up is, do you want to write, should you roll out your own collision engine, or should you just pull a collision engine off a shelf? And then this is kind of what the whole presentation is going to be, is what kind of things do you run into? And my opinion is, even if you're going to use an engine like Box 2D or the engine on Unity, you still really have to understand computational geometry, you still have to understand physics, you still have to understand all these things you're going to need to write your own engine anyway. So you still can understand all these concepts either way. So that is where I'm going to actually go into the demo I have. So this is a Box 2D, and this is sort of this is a game that I wrote for well, first I wrote a game in 48 hours that used Box 2D to make like a side-scrolling game. Yeah, okay. So that's one of the issues that I was coming up with. You can actually use the mace to fly. Because, yeah, it's a feature. Well, so one thing I kind of envisioned was like, so this game was the game I made, and there was like tons of these little wraith guys coming at you, and what I wanted to have happen was like, I wanted to swing his mace, and I wanted them all just to kind of go flying and hit the walls and explode and stuff. But in order to make them get hit so hard that they just fly across the screen, I had to like make the mace so heavy, and then once I made the mace so heavy, I had to make him have a superhuman strength to swing that mace. And then once I put those two things together, you wound up with this crazy, you know, now I can, now I'm like Thor, right? But so this is my, I wanted to expand on that game and make new creatures. And so one interesting point, you can see that these little blobs are attached to the walls. And actually also had a very good presentation last month where we were talking about what were those little guys in Metroid called?
Zoomers.
Yeah, the zoomers. Like, you know, making zoomers when you have like tiles and they can only go like in two directions is kind of easy. But then once I started trying to make them attach to anything at any, you know, any sort of normal and any sort of geometry, things got like really complicated. So it took me like a month of just like playing with ways to get those blobs to stick to those walls. And that's using Box D, because it wasn't built into Box D. I had to try to like put it in there. So then I had different characters. I had a little thief guy. We can do a wall jump.
But he doesn't have the mace of flying.
No, he doesn't have the mace of flying, unfortunately. Who else did I have? Oh, right. Here's like a wizard who can teleport. Here's another issue, is you can teleport into the wall. Because all it is like a line. It's not, there's no volume. There's no like solid object here. It's just, they're just edges. So that disappointed me, because now this is going to be like very difficult to do at this point. But yeah, then I also have this little elf guy. All these monsters kind of get in the way. It's kind of annoying. All right, here's a grappling hook. It's very interesting. It's kind of buggy. I was gonna make a game with this, but then like just all the little bugs that were kind of creeping up. I'm just like, you know what? It's a lot of work to get into that. Okay, so this is kind of illustrating the problems I was having. So adjusting reactions indirectly, you can fly by swinging the mace. So if I made an engine myself, I wouldn't try to like simulate the physics exactly. I would just say, okay, if the mace hit them, just give them some crazy force and launch them off the screen. Bam, that would have been really easy. There's another thing that was actually really hard to see, is the ghost collisions with internal edges on the tile map. What happens in Box 2D is if you have two like squares that are right next to each other, a lot of times if you just try to walk across the top of it, you'll like bump on the edge in between. So if you have a tile map, where everything's a little box, your guy can sometimes trip. And I see that happen in a lot of box 2D games where they don't properly use this mechanic. Like if you notice that with the wizard, he could teleport inside the edges because they were just edges. They weren't like solid objects. So this is how the edges just kind of hook to each other with these like ghost edges to make sure the ghost collisions don't happen. Projectiles sometimes got really funky. So I made the really hacky wall constraint. There's a thing called a prismatic joint. And what I would do is I basically hacked it to make it stick to the wall, and it wouldn't work in certain situations. So like as soon as I tried to hook it to something that was in motion, it would break it. Yeah, so it's very difficult to detect solid edges.
So these are the problems that you ran into because you were using canned collision detection system, right?
Yes, exactly. Well, I mean, a canned collision detection that was designed for like physics and simulation of physics,
As opposed to using your own, though, right?
Yeah, as opposed to using just a side-scroller tile map engine. You have to do things within the constraints of that system. So in order to like actually make things stick to the wall, I was going to have to make my own constraint for it, and that was going to, I don't really know the physics for it yet. So, I kind of went back to the drawing board with this because I really didn't want simulated physics. I wanted something that was more like Castlevania or something. So this is a game that's a little demo on the Wild Bunny site. The Wild Bunny is in the references, and he is a guy that worked on Little Big Planet for PSP. So he has his own website. It's all about game design and collision detection, and he designed the collision engine for Little Big Planet on the PSP, and he said he had to use some of the concepts, specifically speculative contacts, to make it run fast on the PSP. So we're going to talk about a little bit how that works. So now I'm going to get into like, how many people are actual like developers in here, like engineers? So you might be the only guys who really want to listen to this. Yeah, actually the one guy that wanted to hear it had to leave, so that kind of sucked. But anyway, so when you have a collision engine, there's lots of objects flying around, and you kind of have to split it in two different phases. You have a broad phase and narrow phase. The broad phase of your collision detection is basically just kind of narrowing down like, okay, this object is in another part of the world and this object is in another part of the world. So I don't even need to test if it's touching each other. It's I don't need to like test the individual geometry of the two objects to actually do it. And actually that's the easy part. There's lots of books out there on how to do the broad phase and do KD trees and all kinds of like fancy data structures for doing that. It doesn't really affect the dynamics of the simulation much. Like I could write a bunch of different broad phases for the same engine and have it, pretty much function the same way. On the narrow phase is the one that I'm more interested in because that's where it actually gets into more. It actually gets into the more detailed interactions. Like, okay, now I have two boxes touching each other. Like, where are they touching? Is it touching on the right side, the left side? Is it tilted? Is it touching on the point? Is it touching on is the edges connected or what? So, these are some important concepts you might want to look into if you ever want to do a collision engine raycasting, just shooting an arrow out into space and seeing if it touches something. Separating axis theorem, that's for people that really, really want to jump into the details. Another crazy algorithm right here. I'm going to show you what that is. Speculative context, ghost collisions, and polygon skins with other halls. I needed all these concepts to go into my engine that I made. So your separating axis theorem is interesting. If you go on to the MetaNet software, anyone heard of N? Anyone play N or N+? Okay, yeah, so that's MetaNet software, and they have lots of tutorials on how to actually build an engine like they used. So basically what they say is if you look at it, here's a box, here's a box. This is an axis, this is an axis. If it's separated on this axis and it's separated on this axis, they're not touching. if they're touching on all axes, like if these two, if the red line and the blue line were touching and the red line and blue line were touching on both of these axes, then you know it's touching. And that's like actually a really simple way to figure that out. This is a more complicated version of it. Basically, when you sum these two shapes together, you get this crazy shape, and then you kind of you're basically collapsing this box down to a point, and then you can use all the, it really simplifies the collisions. Basically, you just see, okay, what side is this point closest to, and that's how you can tell how the two objects are touching. It's interesting. And then this is also interesting. Basically, there's a distance test where you can find the closest point on two objects, and that's really important for speculative contacts. It's very important for making a very fast but stable physics simulation. You know, and these are queries that you need to write. So
now all three of those algorithms, right?
Yes.
They're all determining whether objects are in the same space and how far they're in the same space.
Right, and like how are they actually touching? Like, you know, this one is saying, you know, is it touching by a point? Is it touching by an entire line? Is it touching? Like how much is it penetrated in there? Is it?
Are there advantages and disadvantages to which algorithm you choose to use, or you use a combination, or do you use algorithmic? I mean, do you use different algorithmic calculations depending on the nature of the game, or at various points in the game?
Well, so the engine that I'm going to demo at the end, and this is kind of this whole presentation about this engine I made. Is I made this engine so simple it only used it literally uses two functions. Like I literally was able to make a very stable 2D side-scroller engine with two functions, which I was really impressed with because I spent hours and hours writing all kinds of crazy functions for, you know, like, oh, if depending on what the last position the box is in, depending on what the position this box is in, like things will tunnel through each other. And we'll get to that. So anyway, so speculative contacts, essentially what you're doing is you're finding, so if you look, this is the closest point on the two shapes. Does this make sense to people? I don't think they really. So what you do is you kind of create this like imaginary threshold line for the entire object, and you're basically just clipping the velocity to hit this like imaginary line right here, and that's what ghost collisions are being created by. You know, like you're restraining the motion to here, but you know the object is only comes up to here. But if you don't do that, then you get these things called this thing called tunneling, where in one frame you have a ball, and in the next frame, because of how fast it's moving, it appears on the other side of the box, and then you've missed that collision. That collision's, you know, and that was
frames.
What?
It happened between the frames.
Yes, it happened between the frames. So that was one thing. I wrote lots of crazy algorithms to sort of like catch those cases, but you know, I thought this wasn't going to work because of this crazy stuff going on, but I came up with a pretty nice solution to that. Oh yeah, also I use skin, so like basically every polygon has like a skin around it, so you make sure things don't penetrate each other. You kind of make sure they're in contact, and you make sure they don't
They'll go through.
Yeah, they don't penetrate each other, because then you can get some weirdo things going on. And then ray casting. So actually, the two functions I ended up using was ray casting and the distance query to find its closest points on two objects. Like literally with those two functions, you can write a full collision engine with just those two functions. So basically, you're determining where the ray hit, on which side of the box, what time it hit, and what the normal is of that. Does anyone know what normal is? Probably don't know what the normal is. The normal is a vector that points in the direction of the, pointing away from that face. A vector, vector math?
And it's direction is based on the right-hand rule.
Well, it kind of doesn't matter because you're kind of working in 2D.
2D.
I mean, yeah, but it does come up sometimes, cross products, yeah. Like, is a cross product positive or negative? That's all you're really figuring out. So this is my collision engine that I made after trying to write that box 2D game. So I have one function, there's a distance query. It basically just tells me what the closest point of the boxes are, or if they're penetrating, and what the normal, yeah, here's the normal. And the normal, you can do all kinds of calculations, like how do you make something bounce off of it. And also, I used a sweep algorithm. So what I did is you basically collapse this box down to making this one giant box, and that's what that Minkowski sum was. And then your other box just becomes a dot. And once you do that, then you can just use a sweep. So you're actually sweeping the boxes. You're determining whether, no matter how fast they're moving, no matter like how many frames it goes through, you're going to find out if they connect or not using this algorithm right here to figure out the time that they actually touched. So, but you also run into finding a global solution. Like, it's really easy to find a solution between two objects. And then the other problem you run into is, okay, now I need a global solution. I have tons of objects, tons of things running into each other. How do I find the thing for that? And this is where kind of internal edges kind of come up. Like you see two cases happening here. Like, so you have a box and it fell through the ground. So, okay, what do you do? Like, if you test this box first, you'll push it out of this box, and then you'll push it out of this box. If you test this box first, you'll push it out of that box, and you won't even need to push it out of this box. So you ended up with this situation where you kind of clipped your motion in that direction in an invisible kind of way. Does that make sense? So it actually depends on what order you do things, but I actually found that by using like what I ended up doing is I ended up putting motion in two different things. Like first, I resolve motion and then I resolve velocity. So when I make a box move, I change its displacement, but then I don't change its velocity based on that collision. So basically, if you go back to looking at this guy, what I would do is I would just allow his motion to be clipped for one frame, but it would maintain his velocity, so he would keep going in that direction. Because if you look at it, the next frame, then this will be your imaginary line, right? Does that make sense? Makes sense for Austin. Okay. But so then it won't really matter because now your line's going to be different. So you're only going to lose a little bit of motion on one frame. So that's not such a big deal. And that's ultimately what happens with this is once you make contact with this ground and all these boxes, don't worry, the technical part's going to be done very soon. And then other people are going to understand it, play games. So this is a little too much detail. Maybe someone who's an engineer might want to go through and look at all this. But okay, so this is why I put so much time into actually understanding this. So your collision detection, depending on whether Mario walks into this guy on the side or he steps on the top, there's a difference between life and death, right? So if that's done in a poor way, it's going to be like, oh crap, I jumped on that guy, but I died. What the hell happened? And it kind of kills the game experience. So in my engine, I solved that problem easily. I have one-way platforms, and I had inclines working for a little bit in one of my demos, but I need to revisit that a little bit. But that is a part that needs to be added.
I was going to say anybody that's played side scrollers gets what you're trying to do. It's
right.
not that. Yeah, the methodology may escape me.
Right. Yes. Right. I mean, that's why I wanted to get to this part. That part I kind of realized, okay, there's only two guys in here that really care about what I'm saying. But now this is, you can actually understand this. But the one-way platforms, the way I have my engine set up is it actually tells whether you're going down through it or you're going up through it. So, and I mean, that's actually the same problem as this. If you're, are you coming up from below or going down from above? You know, that's solved in the same way. So also my engine solves this moving platform problem, where you could have and also pushing blocks. Like you could get this weird situation where you have a moving platform with a pushable block on it that you can stand on. So actually that isn't trivial. Just to, if you make an engine, it won't just like magically be able to solve those constraints for you. Like what'll happen, I've seen some people happen is you'll push the block onto the moving platform, and the moving platform will move, but then the block will stay put, and then it'll just fall off and just do weird things. So I had to actually solve that problem. So both of these things work in my engine. Climbing walls, and actually this is interesting because in Mega Man X, you can actually slide down it's a moving platform you can also slide down. And so these things get tricky. Like it sounds like it's not that tricky to do. When you try to do it, I've seen tons of people try to do it in Wolverine Soft. Like every game I've seen people try to make from scratch in Wolverine Soft, it's just like runs into these problems and then ends up the game, they can't make it because they can't even get it off the ground. You know, hanging from bars, hanging from ceilings.
Climbing up ladders.
Yeah, climbing up ladders. Actually, that's one thing that I try to do in my engine is I'm like, okay, I just need a way for the player to go up. Maybe I can just do it all in one easy way without trying to make animations for ladders, animations for all kinds of things.
It depends on the nature of the game, though.
Yeah, well, I got a demo here, and then I'll kind of see more what I'm talking about. Dynamic destructible blocks. So this was a huge issue because I wanted to do this in the Box 2D game, but in order to destroy each one of those blocks, I had to rewire all those edges. If you remember this thing right here, when you destroyed a block, I had to like do all kinds of calculations to rewire all the edges, and that was just a nightmare to try to do. So I mean, I'm doing just as much work trying to use Box 2D as if I just did it myself. So with my engine, it handles, because of this little situation, I can literally just like make blocks appear and disappear, and my engine doesn't even like realize the difference. It doesn't. The internal edges never come up. So that was one thing that I wanted to solve from the beginning. Moving tile maps. So in Mario Builders, this whole edge of the wall like actually comes in and tries to crush you, and this whole ceiling comes down and tries to crush you, and this one actually comes up, and you have this crazy, you know, moving tile map system going on. So my engine can handle that. Shields and fast projectiles. So in Mega Man, you try shooting at this guy, and it just hits his shields and bounces right off. Because I'm using continuous collision detection with speculative contacts and ray casting, no matter how fast the bullet moves, I know it gets, when it hits the shield and when it hits the guy. And then here we have some ray casting machine gun bullets going on. So here's another thing that I was able to actually solve was dynamic stacked objects. So you have Castlevania, where you have these crazy little dragon heads that are stacked up on each other, and when you destroy them, they kind of fall down and create another stack of a smaller stack. That's actually really tough because you have to like calculate, okay, so the moving tile maps would be difficult if you had this situation on a moving tile map, because now I have to say, okay, is the tile map moving? The tile map's moving. This guy has to move. This guy's moving. This guy has to move. This guy's moving. This guy has to move. You know, you have to actually solve all those. You have to make a graph. In fact, actually, my engine kind of just makes a graph to solve all that. Okay, yeah. So, and the last bit is my engine can actually handle joint constraints. Like this is actually a Flash thing I wrote for an animation class where I do constraints. like box 2D. So actually, if all you do is you take your high school physics and try to make a constraint system, what you're going to end up with is very unstable simulations. So this guy actually ends up exploding and going crazy, you know, and it doesn't stay together anymore. How much time do I have, by the way? Do you know?
20 minutes.
20 minutes. Okay, so I can go into depth here. So a lot of this took a lot of trial and error. Actually, this is kind of hard to see. I just went into my C++ test bed and just tried to write tons and tons of collision detection engines from scratch until I finally got something that worked. And now we have demos. Okay, so I'm done.
So question, who in here is using Unity? In general, have you found that it does a lot of what you need it to do? Have you ever had a little bit of heartburn where, Unity, I wish you could do this one thing, but it just can't? Yeah?
I had issues with platformers when I was trying to go up edges and up close and stuff. And when I was trying to make inclines, that took me a little while.
We asked the right question for you, right?
Yes, yes, that was a good addition. That was a point I was attempting to make at some point. All right. All right, why is Flash crazy now? Wow. Oh, there it is. Okay.
Controls.
Yeah. That is.
It's good.
It's good. All right. So we have my player. He glides seamlessly across the little squares. I got wall jumping to work really well. I got, oh crap, oh no. So what's happening right now is Flash's input is delayed. This is all Flash. The problem that's happening is 100% Flash, where I hit up and it doesn't quite jump until like a minute later. So I got pushable blocks. You can stand on the block. You can even slide on the side of these moving platforms. And then things can move really fast. I have lots of fast-moving objects. And also for debugging, I like to put things in that I can do single steps. Oh yeah, now it's getting slow. Flash is terrible, by the way.
We know.
Yeah, I know. See, this is one issue I have. Like, if I could go back and kind of work on a lot of stuff again, I would just stick with C++. I shouldn't have bothered messing with all these other, like, I worked with X and A for a little bit. I worked with Flash for a little bit, but like, they get deprecated and you lose all your code. Because then, you know, now ActionScript, I don't use the ActionScript anymore. I lose all my code. You know, X and A was a little better if you used a lot of C# code. Yeah, now it's really screwed up. Thanks, Flash. I have to reload the screen. Reload. Yes?
Question, to what degree did your physics engines, to what degree were they non-deterministic?
Non-deterministic.
Or deterministic?
Actually, I think that my engines are completely deterministic.
Okay.
Like 100%.
Okay.
That answer your question?
Yes.
I mean, that might be a stretch.
So one of the reasons that I'm feeling heartburn with Unity right now is that I really want to implement a replay system.
Yes.
And I really do not want to store the the state of every single object in the game, every single frame.
Yes.
And unfortunately, Unity's physics engine, PhysX, is not deterministic.
Right.
So if you do recording of player inputs, you'll quickly find out that, yeah, everything kind of diverges pretty quickly.
Yeah.
So.
Actually, the way I sort the contacts, so the way that I get, like, you get the moving tile map, and actually, let me get to it.
The same thing, problem with network games.
Yeah. So, actually, let me get there. Am I touching anything? This is the problem with Flash. It's like, what the hell?
Major delay.
Yeah, I know. Like, what the heck, man? I'm so thankful to be programming in C++ again. Like, I don't have problems like this. Like, are you serious? Like, what the heck? Anyway. So anyway, what we have here is, here's a demonstration of my moving tile map. So the tile map itself is actually in motion. So actually, to answer your question, what I do to make sure that everything stays in order is once I get all the contacts assembled, I actually sort them in a specific order so they're done the same way every time. So that's how the ship moves first. And so a lot of things what will happen is like they'll just have a whole bunch of contacts and they're going to be in who cares what order. And then they're just going to iterate through like 10 or 20 times and converge to a solution.
That also implies a fixed time step, an integer, or fixed point math. You're doing those things?
Oh, you mean for
just for complex determinism?
I mean, aren't floating points?
No.
If you're on the same processor, like
I wouldn't trust it.
You wouldn't?
Would not,
It worked in Flash. So I made.
But Flash is running on a virtual machine.
It is. That's true. But virtual machine is using doubles under the hood. Yeah.
So apparently, Box 2D, which you were using, has a fixed point mode.
Okay.
And I haven't figured out how to get it running with that.
On Unity?
No, so just Box 2D in general.
Oh, C++?
Usually, yeah, it usually uses floats, somewhat non-deterministic, but you can get it to do fixed point.
I think all you do is you go and you type fixed and instead of like it has a number, and all you do is you change like what, like instead of saying it's float 32, but all you do is you do a type def that says instead of a float, it's a fixed number.
Okay.
And that's all you do.
Okay, I tried doing something like that.
Okay, I think that's okay. Maybe that's not how you do it. I think I have to look at the code again. We can look at it. We can look at it. But okay, so I can't show what the cool thing about this is. If you notice this box has another box on top of it. Really? Come on. But anyway, this little box right here allows you to actually hang on these tiles. Like you can actually use it as a
ladder.
Yeah, like well more like monkey bars. A ladder that's diagonal. I can't believe that. It's like the delay is so retarded. I shouldn't have choose that word. It's ridiculous. I'll correct myself.
Well, technically that is the correct usage of the word.
Thank you. Okay, well, Flash is killing my. Oh, I wonder.
Because it comes from the French retard, which is slow or at a later point than one would expect.
Right.
So, a lagging input is fundamentally retarded.
Yeah. All right, there's my those constraints, and I can get this in there. Oh, no, never mind. Anyway, there's that constraint. All right, let's see if I can get my last one in there. All right, now we have actually some graphics.
There we go.
Oh, good, this one's working. Thank God. So now I just need an animation of him like kind of climbing. And then here's this guy. So one of the things that I really like about this engine is now, so one thing I tried to do in Box 2D is I wanted, I didn't want to try to reverse engineer like an animation and try to get all the physics right for making a guy move. I just wanted someone to animate it and put it into the engine. In Box 2D, I think you can do that. If you modify it, you can actually get things called kinematic objects. But in my engine, it really, if you get someone who just, does animations for you, you can pin it into the system itself, and then this part is actually a moving platform, and it will get integrated into the collision system seamlessly without having to worry about details. And that was really the goal. Is I wanted, we talked about last month about the juice, and I wanted functional juice, things that had motions done by animators, which were really nice and fluid, but actually had direct impact on gameplay. Like it wasn't just you pick up a jewel and jewel flies over to your inventory screen. It's like the motion of this boat affects the gameplay. Now it's like, okay, I'm going to wait till the boat floats at its apex to jump, because now it makes the jump easier.
Which was a quality that Mario had, with other moving platforms, right?
Yeah, exactly. That was kind of the whole point of this engine, was that I wanted to make a game that was just loaded with, dynamic variety. And actually some of these people that make these games, like, what was it, Cave Story? You ever played Cave Story? That game took like 5 years for one guy to make. So I think one mistake I made in, making all these engines was jumping from engine to engine. I should have just stuck with C++. It's a little more of a headache at times, but
you can do everything with it.
You can do. So at the time I was doing this, there wasn't really a great way to like market a game you made. Like I wanted to just make a game and just get out there that people could play, and I didn't care if it made money. And there wasn't really a way to do that until like Steam came out. Like it was Steam, and now with like the store, now it's huge. Like now if I made a game C++, I could put it on Steam, I could put it on Xbox, I could put it on PlayStation 4. You could even compile it to Flash if you wanted to, actually now, because there's an actual compiler that compiles C++ code to Flash. But the only reason I was using Flash is because, I can put it on the web, everyone can play it, and great.
No barriers to it.
Yeah, no barriers. They just play it. And actually, I put some games on Congregate, and actually one of the games that gets played the most, like I got 50,000 plays in a game that was basically an old QBasic game. It was literally a Snake Tron game, and it got 50,000 plays. I was just like, wow, that was like the simplest game ever, and it got more plays than my other games that were really fancy. Like, actually. So I put this game on Congregate. It's basically a top-down shooter that has massive amounts of monkeys coming at you. This is done in a 48-hour game contest, and I was gonna make a fancy game, but then like we kind of got one enemy. We had like different enemies we were gonna make, but after we made one enemy, we're like, okay, that's a long time. We need to just have like one enemy and have tons of them. So, we made this game. So this game uses floating points, and my replays worked. So.
There were limits how far you could take it.
Probably, yes. They were. Actually, I did notice that every now, like once in like 100 plays, something weird would happen. So I have to remember that fixed point. So anyway, that's. So this is what happens when I get creatively frustrated. My my engine doesn't work, and I just need to do something creative because I can't make my game.
It's either that or go to a book depository. Gotcha.
Yes. So, any more questions? Yes.
You keep talking about the box 2D.
Yes.
I'm assuming that's an off-the-shelf 2D engine.
It's actually a free open source engine.
Free open source. So, for 3D we have Unity, we have, we've got 20 different engines that you can use off the shelf. So for 2D, if you want to make like a Mario game, are you for the most part on your own, or do you have to use like a 3D engine and try to get the version?
Yeah. So that was kind of like the whole. Maybe I didn't get that message out, but like. The whole thing was like, yeah, this is what happens when you try to make a platformer like Mario in a fancy collision engine like Box C. You run into all these problems. So, yeah, you're gonna be on your own, trying to make it work like a platformer engine, or making your own platform engine. So yeah, you're pretty much on your own.
Very cool.
Is there a 2D engine that has solved most of the problems that you're talking about?
Not one that you can just kind of get off the shelf, or it's open source.
So the constraints are either licensing, and that's always the issue. That when you have open source stuff, just in general, the problem is that when people will develop stuff and put it out there under a variety of open source licenses. When you come up and say, okay, I found this, but I have a problem with it. It's doing this. It's not detecting when I hit the wall, or it's not detecting. Debug it for me. They're like, well, dude, it's free, so you're on your own.
And you have the source code, so have at it.
Good luck. Let me know how it works out.
Okay, so you would think the industry as a whole, in general, would benefit by having an open source 2D engine that has all these problems, which have solutions already.
Right.
It sounds right. The challenge is that if you stop and you think about it, and you think about doing, as you said, you think about doing innovative things in the game. Everybody wants to do something that's never been done before. It would be really cool if you didn't stop when you hit the wall, but you were able to climb up the wall. If the platform that you were on wasn't just stationary, but it was moving. People always want to do something innovative.
I mean, that's like actually what my engine is kind of for, is so you can jump to that and not worry about, it doesn't even like stop, it doesn't even like hit the platform, it goes right through it, and it doesn't even stand on the platform. Actually, I was gonna do this, I was gonna make an open source Flash version of it, but then I just said, I'm kind of done with Flash. I started doing C++, but then I ran into, okay, now I'm doing C++, and I have all these memory management situations to worry about, and I'm just like, actually, that's kind of what this is kind of led me into, is now I'm learning about entity frameworks and data-oriented design. So I'm just like, the new thing now in C++ is...
Now you got a GPU accelerated.
Yep, exactly.
So perhaps if the industry can make an open source general 2D engine, perhaps I think you can do that.
And I was thinking of just putting my engine out there, but I haven't written in C++ yet.
I'm come back mostly though to recouping funds. I mean, it takes time and man hours, and especially if it's a studio, like didn't Stardock create their own engine as well?
Well, several of them.
And I mean, if they were going to put out the license, correct?
Yes, we're commercial MP, we would love that.
Yeah, I mean.
See, mine's awesome because it only took me 2 days to actually make it. Like it took me like years of just playing with it, but when I finally got it right, it only took me like 2 days of writing code. That was beautiful.
So there's sort of two issues on it. One is the licensing solution. Whether you have a commercial or non-commercial license. And the second thing is support. So we can all agree that there may be benefits in having an open source, free. Here you go, make your own thing with it. Except when the person calls you up at 3 o'clock in the morning and says it's not working, or I found a bug in it, who's supporting it? That's the other challenge that comes up.
And there are models that do that. Work with companies that make open source networking software. Well, you can buy a support contract for $20 grand a year.
Right.
And have done quite well with that model.
that if you take a look, at, you know, I would offer,
Linux
Linux
want
as
to
an
just
example.
go to normal.
Companies like Red Hat, right? Here it's free. Knock yourself out. Go do it. If you want support, that'll cost you.
I want to interject one thing, which is the problems you've gone over here. I've run into most of these specific problems in commercial games, like you guys running against a wall, you get stuck in the wall. There's a bomb that goes off. Oh look, you're suddenly in the wall. Or one of the NPCs is in a wall. Trying to tweak like how far out do you project those collisions versus how much CPU time does it have versus how far out in the scene do you go? Like you really have to tighten those constraints. And then the numerical explosion. Like
right, numerical explosion.
Two things intersect with each other a little bit, and suddenly your car is 200 feet in the air. So these are real commercial
Did you
problems.
ever play Lightweight Ninja? It's a pity Scott's not here. But so Lightweight Ninja was one of the first games. Akil, did you ever play Lightweight Ninja? Yeah. So Lightweight Ninja was really good. Side scroller with menacing squirrels throwing acorns down at you.
Oh, that one.
Yeah. So the hit detection was slightly off in that. And oh, did we get cream in the reviews? That you could actually see width between you and the bomb that was coming down, but you died anyway. Not PC, it was Windows. So listen, I was going to say that some of the things that I've been impressed with. I had a brief foray into mobile, and now Halfbreak does some amazing stuff with collision, with detection. In Fruit Ninja, I mean, they nailed it. But one of their other games, Jetpack Joyride, has really nuanced detection because there are times that you have to get close to things but not hit them. And works great. I mean, I don't know what they did. I don't know what goats they sacrificed to make that work, but it worked.
Well, couldn't you just have invisible box around?
I'm sure that there is. I'm sure that there is an invisible box. I'm sure that's the way it's done. I got the concept on that too. It's the execution of it that eludes me. You know. I also understand the physics of slamming a basketball. I just can't do it. You know. So it's a slight difference between me and LeBron.
So one really good AAA example of collision issues are Bethesda games. So who's played Elder Scrolls Oblivion? Yeah? So if you go back and play that game, I'm pretty sure that if you start walking down any sort of slope, you'll notice something very interesting about the walk. It isn't like you got a slope, you go down the slope smoothly. What actually happens is you press the arrow keys, you get some velocity, you jet out into the air, you start falling, you eventually hit the ground, at which point you can then apply more velocity, you go out again. So it's not like you're walking down a slope, it's like you're falling repeatedly down the slope.
That's invisible stairs.
Yes. And everyone knows you can climb up. There is no unclimbable mountain in Skyrim or Oblivion.
Could you climb on the bottle? Like you could hold a bottle and stick it under your feet and then jump on the bottle and actually like get up in the air?
I think Half-Life had that problem too.
Ultima 9, you could bake bread, stick it in, jump on it, take bread, put it on you.
Right.
And these are classes of problems that come up in every game.
Yes.
That's good for speedrunning.
Yeah, a lot of little collision bugs are wonderful.
I'm trying to remember whether it was it Mario 3 was one of the underground levels
after I learned
that actually had
2D.
you accelerating as you were going down. That was part of it, and everybody was like, I never imagined that before, that you actually accelerated as you were going down the slope. You had to get up before you went too fast.
Oh, Mario 64 or something.
The other thing, to answer so many questions, the other thing that happens, and happens all the time with games, is that no matter how much you QA test it, when you get over a certain number of users, they find things that you didn't know you had in the game.
There's just so many more of them.
Yeah. I mean, you know that thing about if you had enough monkeys and enough typewriters, they would eventually type the Bible. You find that there are real world stuff that who would ever have thought about doing that, you know?
And so some of this is due to modeling is not mistakes.
Yeah.
Okay, any other questions? Okay, Jason, thank you. Okay, do we have any community announcements?
We have some sort of Unity event coming up, I heard.
Yes. So on June, our June meetup is actually going to be a little bit earlier in the month than normal. June 4th at Lawrence Technological University, Unity, representatives from Unity are actually coming to see us. So if you have any questions you want to ask about the engine, if you want to learn about the future of the engine, what's coming, then that's going to be a fantastic event for all of us.
Can I make demands?
My party spoke to you as God answers every prayer as long as you understand that no is also an answer.
Additional announcements. You are free, and if you're free on this Saturday, and there's an LTU Anime and Gaming Con, which is going to be showcasing all of the independent game studio games. So there's a bunch of students who've got games that want to be played and showed off. Also, it's going to be the first time that there's going to be an available demo for the Dreaming Door games, Golden Treasure.
What are the dates and location again for those in the back?
So it's Lawrence Tech University, and it's going to be this Saturday, the 21st, from 10 to 7.
Yeah, there's also lots of anime happening.
There's anime stuff happening, game stuff happening. All the IGS students are showing off their projects, and there's going to be that demo.
If you send one of us an email, we'll put it up on our website for everybody.
Yeah, and I'll probably toss it in the Discord as well, just announcing it to everyone who's here.
So on that note, we should also mention there is now a Michigan statewide game development Discord channel.
So we can shoot out the link to that in the next email that goes out. Quick question, Larry, is this your last IGDA?
Close.
Close?
So I'm getting ready I'm heading out to Vegas at the end of this week with the intent of buying a condo out there, and this may well be my last IGDA meeting here. I have been told by IGDA headquarters that Vegas has a slow-moving chapter, and maybe somebody can go out there and invigorate it. So I'm going to rise up to that challenge.
So, ladies and gentlemen, Larry Cooperman, our founder, has done so much for this organization. It did not really find a home here at Spark. It did not begin to explode like it has until Larry showed up and started just putting in
annoying the hell out of people.
putting in tremendous amounts of work. All he has done for us. Larry, thank you so much.
So thank you very much. It's been a pleasure. It's been a great year and a half, and I do intend to come visit when I'm back in town. In the meantime, everybody's got my contact information. I am not going into a hole in the ground. I'm going to Vegas instead. But I'll be happy to facilitate and help with things. Getting the relationship going with Unity was one of the big metrics. One of the other big, finding us a home at Spark was a big one. Getting the official recognition from IGDA was another one. Getting Unity has taken us to the next level. Having the Discord channel so that there is game development in Michigan. Statewide has been a big thing. And on my way out the door, I am trying to build up a relationship with NVIDIA. So they make some kind of graphics cards or something. Thank you all very much.
Thank you,
If you don't need, I have to figure out. Well, no, you can also have to figure out how to put it.
There you go. So grab some pizza. Feel free to walk around, talk, network a little bit. Next 30 minutes. Thank you all for coming. All right.
Are there two in June or just the one?
So it's just going to be the one in June.
Did you say Tiger? Yeah, no, I got a client call at 7 a.m. So I was up, and I live in Northville, so I was up and driving here, and I had to be ready for conference call. So, till 5. Third Thursday is a long day for me, but I come. As long as I don't have to read it. Hey, thanks for doing this. You know, these sauces. And,